Hello, and welcome to the AWS Partner Webinar Series, where our topic today will cover how to deliver SQL Server high availability on AWS and managing your business-critical applications. My name is Sherry Sullivan. I'm your host today. I'm with the Partner Marketing team here in Seattle, and I'd like to just cover a couple housekeeping items before we get started. We are recording today's presentation, and we invite you at any time to submit your questions through the Q&A widget in your browser. We'd also like to let you know that we'll make this content available after the event. You can find our partner webinar series on YouTube as well as SlideShare. We've got a great topic today. Well, we will cover deploying SQL Server on Amazon Web Services, and we are joined by our advanced technology partner, Sanbolic, who will cover some solutions for SQL Server customers around storage, data management, and app management, and we'll see a demo of their technology solution. We'll close the webinar with some time for Q&A, and so please feel free to submit questions. I'd like to introduce our presenters today. We have Bill Stevenson, who's the Executive Chairman with Sanbolic, as well as David Dupuis, who is the Director of Enterprise Solutions, and our own Senior Solution Architect, Miles Ward. So without further delay, I'll hand it to you, Miles, to take away.
Sherry, thank you very much, and I appreciate everybody joining us today for the webinar. What we are pretty sure you already know, if this is a subject that you're interested in, is that Windows runs great on AWS. We've worked together very closely with the team from Microsoft and have made significant investment in innovation around ensuring that the Windows experience on AWS, and by extension the SQL Server experience and other Microsoft product technology experiences on AWS, work smoothly, are easy to use, and allow you to get started in minutes rather than months. This is something that we're seeing very broad adoption across numerous different customer verticals, and very excited by the growth that we're observing in that space. So we have a lot of folks that have asked us about the differences between running Windows in the cloud versus running Windows and SQL Server workloads in their on-premise environment. So a couple of sort of places where our stuff is probably much more similar to running Windows in a standard sort of local way than you'd expect. We're using real, full, licensed Windows Server operating systems. We're licensed under the Microsoft SPLA program, so you don't need any CAL, and that means that you also have access to a different product SKU for SQL Server called SQL Server Web, which we'll talk about in a bit. We've also made it so that we're available to run Microsoft SQL Server 2012 and Windows Server 2012 just recently. We have a whole network environment called Virtual Private Cloud that makes it very, very straightforward to build static, user-defined networks that make it simple for you to build things that probably look just the same as the data center or office facilities that you're used to. We've implemented at the hypervisor layer a system of tools called security groups and network ACLs that give you all of the sophistication and control from a network access standpoint that you're used to with firewall appliances or software controlled by our APIs. So provides the same level of security and control, and in many cases better levels of security and control than other places you can run this kind of service. And we've made it very, very easy to install the services and software that you're familiar with using the Microsoft License Mobility Program. So we think that that's pretty approachable, pretty standard. There aren't these big complexities that make it difficult to run in the cloud. And as a result, we've gotten a lot of uptake from enterprises trying to figure out which projects they'll move first, how they'll take advantage of cloud for their workloads. So we've got many, many different instance types. This is the pricing for EC2 as of a couple of days ago. We just today announced a reduction in our reserved instance pricing, so certainly recommend everybody take a look at that. But as of yesterday, this is what it costs to run an integrated license for SQL Server Standard or SQL Server Web, along with the Windows license on an hourly basis. So I'll say that again. You don't have to go buy a packaged license for Windows or SQL Server. You can rent that software from Amazon by the hour. And the SQL Web environment allows a much lower price point for SQL Server usage backing public web applications and websites. So we've also added quite a few very high-scale instances for the biggest workloads to ensure that our partners in the enterprise have the ability to run even their largest workloads with us. So we have instances with nearly a 1/4 terabyte of memory. We have instances with 2 terabytes of local solid-state disk. We even have instances now with 48 terabytes of local magnetic storage. So very, very high scale. The CR1s, for example, have 16 cores available. So very high performance, very high scale systems, really incredibly well suited to the database workload. We've also added a service for relational databases. So AWS has a service called RDS that allows hosted and managed SQL Server environments. And what that does is we control the provisioning and management and delivery of that service and make it very, very simple to get started and to use what I'd characterize as sort of medium scale and small scale systems. It's one of the reasons that we're excited to partner on this conversation with Sanbolic is they have some technologies that allow higher scale and higher availability options in this space. So we know the first question that you'll get asked when you talk about not just moving, say a dev test workload or a web workload, but the real, core of your business into the cloud is questions about security. So AWS is built around a very consistent concept, the shared security model or the shared responsibility model for security, which has been proven over and over again with hundreds of thousands of customers in 190 countries around the globe. That this model where AWS is in charge of the physical facilities, the security in and around those facilities, the design and deployment of the physical infrastructure and the network infrastructure and the virtualization infrastructure above that, creates a layer of separation where you offload that work to us, you entrust our engineers with building all of those systems in a best practices, highly certified, highly technically accurate way, and then your responsibility is the design and configuration and implementation and controls around the operating system, the applications that you install, and the configuration of the services above us. So that shared model, one, means that, in order for us to do, the right thing, we need to make sure that we're holding ourselves to a very high bar to the level of security sophistication that our most secure applications, that the customers that are working with the most private data can be comfortable with. So we've completed our SAS 70 Type 2 audit and updated that to an SFA 1632 audit with a SOC 1 compliance certification on a quarterly basis. We have an ISO 27001 certification and can support all of the levels of the PCI DSS spec, including PCI Level 1, which means you can build a credit card processor on top of AWS. We've even helped customers work through the process of building whole solutions. You can't just certify one part of a solution, but whole solutions that meet HIPAA compliance, SOX compliance, and the requirements for FISMA moderate. So we've done a good job. We've done our due diligence, and we've done the work with our partners in certification to ensure that everybody knows exactly what we're doing to protect systems. We've also designed patterns that you can use in application and service design and services like identity and access management, multi-factor authentication with our little tokens for the ability to use two-factor auth when you log into systems, and all of the controls that are available to let you build highly secure systems. So from an architecture standpoint, that ends up looking a little bit like this. You will likely have your corporate data centers or your facilities that already exist, or the systems that you're in the middle of end-of-lifing and looking at migrating to cloud. You want to build a connection from those systems that's secure into our systems. You can do that using our VPC and the VPN hardware gateways that it exposes. You can run VPN software inside of Windows, and you make those connections also as well over Direct Connect, which is a physical link to our network facilities over private fiber connectivity by way of our peering points. So let's maybe talk a little more specifically about SQL Server on AWS. A couple quick examples. We worked with systems integrators, Second Watch and IT Lifeline, together with one of their customers, the Red Line Hotels Corporation. They migrated their SharePoint backed by SQL Server, and they also used SQL Server to back the Umbraco CMS system. That cut some 58% out of the cost for running and maintaining the SharePoint and SQL Server environment on top of AWS, while at the same time delivering significantly faster network speeds and improved load times for their application. Another great example, SharePoint and SQL on AWS powers recovery.gov and treasury.gov and indeed many, many different primary sites for some of the three-letter agencies from the U.S. federal government. We worked together with folks from Interactive Smartronics and saw the same kind of 60 to 70% savings in these deployments, as well as quicker time to market. So we have a lot of customers that take this set of ingredients and their current designs for high availability and disaster recovery compliance, particularly for their database designs, and they'll sort of forklift that over onto AWS. They forklift the pattern of having a master and slave database, but they think of a data center and having multiple data centers as a pretty expensive, pretty complicated thing. One of the core differences of the AWS design globally is that we're always building with more than one availability zone. And having more than one availability zone creates all of this fault tolerance in your design because you can spread systems at really incredibly low cost across a pair of availability zones. The only additional charge there is the network cost of moving data for replication from one side to the other. So if your application today is deployed in a single availability zone, we really strongly recommend distributing that workload across to a secondary availability zone inside of the same region. That provides very, very high performance fault tolerance design. Internally to the AWS offering, we've built services that allow multiple different replication architectures, right? You can use, what I think some folks would call kind of the older services from SQL Server. So you can certainly do log shipping using S3 as a centralized container. You can do database mirroring using another EC2 instance as a witness. You can do transactional replication with AWS. But I think one of the places where we've been asked a lot about, what are there higher availability models yet than that? I want to use more sophisticated systems for replication. We also have services for storage. So EBS, a very powerful service from Amazon Web Services. Above that, a service called Provisioned IOPS EBS allows you to build systems that have not just hundreds or thousands, but even above 10,000 IOPS for a SQL Server workload on EC2. But we certainly get feedback from customers asking for even higher performance solutions, even higher availability solutions around storage. While many of the workloads, and again, thousands of customers are successful in deploying and managing Windows and SQL Server environments on top of AWS, we're really excited about the partnership with Sanbolic and its ability to add some new features and new capabilities around high availability and around performance, particularly for the storage for Windows workloads. With that, I'd like to hand it over to the fine folks from Sanbolic.
Thank you, Miles. I'm Bill Stevenson. I'm Executive Chairman of Sanbolic. I'm going to make the assumption that while most of the audience is already familiar with AWS, some of you may not be familiar with Sanbolic, so I'll provide a brief introduction to our company and technology before we dive into the specifics of the SQL Server solution. In brief, Sanbolic is a software company that was founded more than 12 years ago to address the storage needs of distributed computing. We have a product, Melio, that is a host-based software suite that is built around a clustered file system. It abstracts data from the underlying hardware and moves high-value storage features into the software layer, which allows customers to flexibly deploy highly available enterprise applications across physical, virtual, or cloud infrastructures. Because there is not a dependency on the hardware, Melio really facilitates the adoption of new infrastructure like AWS while continuing to utilize legacy assets. Now, while there's been a lot of companies popping up or rebranding themselves as software-defined storage over the past year, Sanbolic is no newcomer to this market. Our engineering team began working on the solution in 2000, initially focusing on a telecom network operations center project with Motorola and Nortel that was essentially an early incarnation of cloud computing. We have continued to develop our product over the past decade and now have a comprehensive and enterprise-tested platform available. Our next product release is later this month, which will include extensive optimizations for high-performance, highly available server-side flash. And I would point out that although our software has no dependencies on open source or Microsoft code, we have worked extensively with the Microsoft server, clustering, and database teams to ensure that our product integrates easily and intuitively with Microsoft server applications and extends the capabilities of the native 2003, 2008, or 2012 platforms. Just briefly touching on our customers, we currently have our software in production at over 700 enterprise and government accounts globally, including more than 10 of the Global 100 and counting. The majority of these deployments are still on-premise deployments using legacy SAN storage, but over the past year, much of our customer activity has involved public cloud and hybrid on-premise public cloud deployments, as well as distributed server-side flash storage. Typical workloads for Melio include virtualization, scale-out file serving, scale-out web serving, and media streaming, as well as database high availability, workload distribution, and storage consolidation. Today, we're going to focus the remainder of the webinar on our solution for SQL Server on E2, which uses both our clustered file system and our app cluster application clustering components of our software. With that, I'd like to turn it over to my colleague, David Dupuis, to run through the details of the solution.
Thank you, Bill. So within the Melio product suite, as Bill mentioned, we have this component called App Cluster. This component is really designed to solve problems around clustering of SQL Server. So it's just an individual module within the overall product, and basically it decouples the SQL Server instances and databases from the traditional rigid server and storage bindings, giving customers a more flexible, more scalable environment, as well as increasing the availability. So the typical problems that we're trying to solve around SQL are problems related to storage consolidation, high availability of both the storage as well as high availability of the SQL instances and databases themselves. We're also trying to solve problems around the lack of support for high availability within the public cloud. As you know, traditional clustering solutions like failover clustering don't currently work within public cloud infrastructures. We're also trying to solve problems around the types of clustering you can do. So most people are used to just traditional instance level clustering, where you're limited with the number of cluster nodes you can have with failover clustering. You're limited to the number of instances you can cluster. And we're also trying to address limitations around mixing physical and virtual server resources. And we solve these problems with the Melio product suite. So what we can do is we can consolidate the storage infrastructure, simplifying the overall management by enabling multiple servers to share access to storage resources. We're also enabling both the storage clustering as well as application clustering without any dependencies on traditional Windows failover clustering, while also giving you dynamic scale-out capabilities. So you can add more servers, add more storage, add more instances on the fly without ever disrupting running workloads. We also increase the availability, both from an application standpoint with SQL as well as the storage, which we'll get more into. And we can enable quality of service, both at a SQL instance level and at the individual database level, allowing you to meet SLAs. The Melio platform itself consists of 3 components. At the base, we have the Melio Volume Manager. That is a cluster-aware volume manager that has been specifically designed for shared storage environments. We also have the Melio File System. This is a 64-bit clustered file system that's designed to allow multiple servers to concurrently read and write to the file system. And then the last component sitting on top of the stack is App Cluster. And that's the component that uses this active-active storage access for the servers to provide high availability as well as load distribution for SQL workloads. Starting at the bottom with the Melio Volume Manager. As I said, it's a cluster-aware volume manager, so it allows you to centrally manage your storage from a single node. It's protocol storage agnostic. It also allows you to aggregate internal storage as well as external storage. Allows you to do various levels of RAID from 0, 1, 10, 5, 6, 50, 60 with hot spare support and auto rebuild. It also supports synchronous and throttled replication, storage live migration, so you can actually take an entire storage volume that's actively being accessed by a SQL workload and live migrate that volume to another block storage device without disrupting those workloads. It also supports dynamic volume expansion and the ability to change the configuration without disrupting those workloads. The Melio File System, which sits on top of the Volume Manager, that's providing you the actual shared file system access. So it's a 64-bit symmetrical file system. So being symmetrical, there's no single points of failure at a host level. This doesn't use metadata controllers or coordinator nodes, which are mechanisms that can decrease the availability as well as limit the scale-out capabilities of the infrastructure. It's completely symmetrical. It'll support up to 2,048 servers concurrently accessing the file system. This is also the component that contains the quality of service capabilities that allow you to set those minimum bandwidth guarantees at either an application, file, or directory level. It also has a component called LTA, or Latency Targeted Allocator. This allows you to mix different storage types within a server, and it'll intelligently place the blocks of data based off of how the application is accessing that data. And then there's App Cluster. So the actual application clustering component designed specifically for Microsoft SQL Server. This will allow you to cluster up to 2,048 SQL servers within a single cluster. There's no real limitation on the number of instances you can cluster. It also has no dependency on what editions of SQL Server you want to cluster. So if you'd like to cluster up to 64 SQL Standard servers, you can absolutely do that. Again, we have no dependencies on failover clustering, so we don't have any limitations around the types of the editions you can cluster, the number of nodes you can cluster, or the number of instances that you can cluster. Now, combining these 3 components with the Amazon Web Services allows you to provide high availability and scale out to the SQL servers, as well as web servers and any other Windows-based workload that you can run on AWS. It also can enable you to run hybrid environments where you can mix on-prem and cloud infrastructure if you're using Amazon VPC. So here we can just see a quick snapshot of some sort of competing technologies, other ways that maybe you can solve some of these problems. And the real takeaway from the snapshot is that the other alternatives, replication, cluster services, virtualization, they'll solve some of the problems related to SQL Server, but they won't solve all of the problems. And by having a stack that goes all the way down to the storage layer, all the way up to the application availability, Sanbolic can really help solve all of these issues. Now, when you talk about a shared file system, a shared volume manager, obviously you're going to need shared access to the storage. So how can I get shared storage in the public cloud? I don't have a traditional SAN that I can just plug into my EC2 instances to go ahead and get a shared storage resource that these servers can concurrently access. So there's two ways that you can do this on the AWS platform. One is you can use public cloud storage providers. These are storage providers that essentially have dedicated storage that you can subscribe to, and they'll deliver that storage right to your virtual machines, typically over an iSCSI connection. The second option is you can build your own virtual storage servers. So you can set up EC2 instances to run as storage servers and act as a virtual storage array, essentially. And so here we can see just a little snapshot of a potential architecture of doing shared storage in the public cloud. This is using EC2 instances as the virtual storage servers. So we can see at the bottom there, I have two virtual storage servers. They're in separate availability zones. That way, if I have an availability zone failure, I'm not going to lose access to my data. And what we can see there is they're presenting two storage targets. Those storage targets can then be accessed by all of my EC2 instances, which can be separated into different availability zones. And then using the Melio Volume Manager, what I essentially do is create a mirror across these two storage targets. That way, if I was to sustain a failure of either one of those virtual storage servers, the volume itself would not go offline. It would be continued to be able to access it through the remaining leg of the mirror. SQL Server would notice no disruption in its access to the storage, and I could allow those workloads to continue operating. Now, once I recovered from that failure event, the Volume Manager will automatically go and start resyncing any of the change blocks in the background, so they can bring that back up to a fully consistent mirror. You can also use the quality of service components within the file system to actually control how much bandwidth that mirror resynchronization process is going to use. So if you're on peak hours, you may not want that to go and start using half of the bandwidth available to resynchronize the data, so you can dial that back, let it just do a trickle in the background. If you're off peak hours, you can go ahead and give it a ton of bandwidth to go ahead and just get that resynchronization completed much faster. When you are at a full synchronization, the cool thing is since both targets have a duplicate copy of the blocks, we'll actually distribute any of the incoming read requests across both of the virtual storage servers. So you'll actually see a pretty significant performance boost for read operations. And as you all probably know, with SQL Server, a large majority of the requests are read requests. On the public cloud storage providers, there's a number of providers out there. With Sanbolic, we've partnered with Zadera Storage to deliver public cloud storage to our file system. And the way this works is quite simple. In the case of Zadera, they have a data center with lots of hard drives and lots of storage. And they have a very high-speed interconnect right into Amazon's core network. You can see there they have a 40-gigabyte link right into the core network, and they use that high-speed link to go ahead and deliver you the storage from their data center directly to your EC2 instances. Now, the interesting thing about Zadera is it's not multi-tenant. So if the storage you are renting from them, you're purchasing, it's dedicated. So if you say you want 3 SSD drives, 10 SSD drives, whatever the case may be, those are your drives. There's no other users that are co-located on that hard drive. It's dedicated hardware. Now, so far, if any of this sounds interesting to anyone so far, we do encourage you to go ahead and download a free trial of our product. You can just go to our homepage. You can see in the top right where that big red arrow is pointing. There's a free trial button. You can just go ahead and click, register a quick account. You'll be able to access fully functional evaluation copies of our software. Here we have a quick snapshot of a case study with a customer that's running our software on the AWS platform right now. This particular customer, Roadnet Technologies, they're using it for web servers. So essentially, they have web applications that need access to a single data set, and that data set is updated frequently. So they can't do things like replicating the same data set across multiple independent storage devices. There's the I/O overhead associated with that. There's the consistency issues associated with that, as well as the storage overhead. You now have multiple copies of the same data. And so what they've done is they've gone ahead and used the Melio product suite to give those AWS EC2 instances shared access to the same data set. They update a single copy of that data set, and it's instantly penetrated across all of their web servers. With that being said, I think we'll go ahead and cut right into a demonstration here. So bear with me while I transition to the screen sharing mode. Give me 1 second. Okay. All right, and everyone should be able to go ahead and see my screen. And basically what we have here, I have two EC2 instances currently set up. You can see on the left there, AWS SQL 1, AWS SQL 2. And what the view we're looking at here, this is the Melio Volume Manager. So here we're taking a look at the storage that this EC2 instance can see. And we'll notice that we have 3 disks here right now. The first disk you'll see there, it says Zadera. That's actually a LUN from Zadera cloud storage that I have, and it's a pretty straightforward volume, just a single partition volume. We can see up here, this is drive X. And then the other 2 disks we can see there, those are coming from 2 storage servers that I've set up, Storage Server 1, Storage Server 2. These 2 storage servers are in separate availability zones, and I've just gone ahead and created a 29 gigabyte target on each of those. And then using the Melio Volume Manager, I've gone ahead and created a mirror set of these 2 targets. So I can sustain a failure of either one of those storage servers. It's not going to affect my system's access to that storage. Now this mirror is fully synchronized, so you'll notice here both of the partitions making up this particular mirror set are set to a mirror read source, so any of my incoming read requests are going to get distributed across both of these targets. Now, as I said, this is a 64-bit volume manager, so it will support LUN and volume sizes up to 18 exabytes. As I said, it also has the capability to do storage live migration, on-the-fly volume expansion. It can also do volume sets, stripe sets, RAID 5, 6, 50, 60. And the great thing is, it's a cluster-aware volume manager. So what does that mean? That means it's aware of all servers that are sharing access to the same block storage devices. So I only have to connect to one server and do any of this volume level configuration. If I create a partition, if I create a volume, whatever I'm doing, all the other servers are going to see those changes on the fly. I don't have to go to those other servers and rescan devices or rescan disks to pick up any of those changes. Now we can see here I have two volumes. They've already been formatted with Melio. I have the M and the X volume. And once formatted with Melio, that's when the servers will get the actual shared read-write access. So we can see here in my computer, I'll let the screen share catch up to me here. Shows up just like any other block storage device, except now I can access it from both nodes. So if I was to flip to SQL 1 here, we can go to my computer, and we can see it also has access to the same volume. Now, besides providing shared access, the file system also has a number of other capabilities. It does have its own cluster-aware VSS provider. This allows you to take snapshots of the file system. Now, it's a cluster-aware VSS provider, so what that means is it's aware of the fact that there are multiple servers accessing the file system. And so when our VSS provider is invoked from one node, what it will do is it'll actually synchronize every server that has access to this shared volume. And it'll synchronize them so that they all do a synchronized flush to disk of their cache to get that file system in a consistent state for the snapshot. Once the snapshot's created, it's in the file system itself, so it can be accessed by any of your EC2 instances. It doesn't have to be the server that created it. It can also be exported as an SMB share to servers outside of the cluster that you want to give access to any of the data within that snapshot. Any backup software that supports third-party VSS providers will be compatible with our VSS provider. The file system, as I mentioned earlier, also has quality of service components. These allow you to set minimum bandwidth guarantees at either an application, file, or directory level. So at an application level, what I can do is I can browse for any process within the operating system. And I'm just going to go ahead here and select the SQL Server process. And then using a point system, I can specify a minimum bandwidth guarantee for this particular application. Now, the minimum bandwidth guarantee only goes into effect if the application is running and is performing I/O against the file system. Any of its guarantee that it's not using, we will allow other applications to go ahead and utilize that bandwidth until this particular process needs it. So it's very good, especially if you want to protect your primary workload. If my primary workload is SQL Server, I don't want someone starting a giant Explorer file copy, a virus scan, a backup, and suddenly SQL becomes severely degraded. So with this, I can make sure that my application is going to get the bandwidth that it needs. At a file and directory level, it works on the exact same principles, but instead of targeting I/O from a specific application to the Melio volume, I can target I/O to a specific location within the Melio volume. So in the case of SQL Server, maybe I have a particular database that's of a higher priority. Maybe it's running a more intensive workload, it has more application connections, whatever the case may be. I can use the same point system to go ahead, make sure that that database is going to get the bandwidth that it needs. And I can also do this at a directory level. So I can select an entire directory, and the quality of service assignment will apply to any object that's within that directory, that's within that parent directory. So we can see there, works just the same way. And again, just using the same point system. Now, I'm changing these through user interface. Can be changed externally. So you can have something set up to go ahead, and if it's based off of certain times or certain days, you can have these quality of service assignments dynamically change to meet changes within the workload based off of certain scheduling. There's no reboots or anything required for these assignments to take effect. And then the last component is App Cluster. So we can see App Cluster here. This is the component that actually clusters SQL Server. And so it looks a little bit different than your traditional Windows failover clustering. It functions much differently. It uses the concept of resource groups. So what I can do is I can create resource groups, and then within those resource groups, I can assign resources. Now, those resources can be entire SQL instances, which would be like a traditional failover clustering, or they can be individual databases. So if I want to do database level clustering, and what that'll do is it'll let you run active instances on multiple servers. It'll just cluster the group of databases and be able to fail those over in between the instances across servers. So for some environments, that gives you a lot more flexibility and compared to just clustering an entire SQL instance. But as a user, you have the choice. In this particular configuration, we're using it for database level clustering. So we can see I have 2 resource groups, and I have 2 servers. And right now, each server has 1 resource group. I can also use weights with these resource groups. So you'll see down here, I have group weights. This gives you the ability, what you can do is you can set weights for the server, you can set weights for the resource group. So on a resource group side, it's how much load will the resources within the group produce. On the server side, it's how much load will a particular server handle, which you might change depending on a number of virtual processors, amount of RAM that's within that particular server, etc. And those weights come in during a failover event. So when a server fails, not only will we fail the resource group over to another node, we'll intelligently fail it over. We'll fail it over to another node that's under the least amount of weight, so that you're intelligently distributing this load across the servers within the cluster. Now I'm going to go ahead and just kill one of my virtual machines here, so we can introduce a failure. And while that's taking place, also in addition to doing server weighting, you do get your traditional preferred servers. So if there are certain servers you would prefer to run certain workloads, you can certainly specify that. We also allow for tolerance settings. So if you're doing database level clustering, maybe you've got 1,000 databases within a single group. If one database fails, you may not want to go ahead and fail that entire group of databases over. So you can set certain tolerance percentages. We also support virtual IP addresses. In the case of Amazon, we actually have hooks into Amazon's API so you can associate elastic IPs with a particular group. That way, if you have external applications that are accessing those SQL databases or a SQL instance over an elastic IP address, we can fail that over too, so that the applications can continue to access the data. We also have the ability to execute automated scripting. So if there's something we don't do, you need to have happen, you could go ahead and write your own script to do that. And that can execute on a server we're giving a resource group to, or on a server we're taking a resource group from, or both. As I said, with App Cluster, there's no limitation no realistic limitation on the number of servers you can cluster. It'll support up to 2048. There's no limitation on the number of resource groups or the number of databases or on the number of instances you can cluster. We also allow you to mix different versions of SQL Server within the same cluster. What will happen is if you're doing database level clustering and you're mixing versions, the databases, you can actually specify what version they're allowed to operate under. Now, my servers, I only have one version installed, so I don't really have any other options. And so it'll lock to that version. It'll only assign to instances that are actually running that version. Now, if you go ahead and upgrade a server to a new version of SQL Server, you can just go ahead and tell your databases you can now operate on this new version, and App Cluster will automatically migrate those databases over to a server that's running that new version. You can also transfer what operating instance they're allowed to operate under. And that's that with App Cluster. So essentially providing you not only failover capabilities, but also load distribution capabilities. With that being said, we'll transition back to the PowerPoint. And we should be back in live view mode. So if anyone is interested in either seeing a one-on-one demonstration, we can go more technical detail of how this works, and you can get a one-on-one demo of how this integrates with the Amazon platform, please send an email to sales@sanbolic.com. If you just want a one-on-one technical discussion, email sales@sanbolic.com as well. Also, we do have special pricing for anyone that attended this webinar. So if you are interested, reach out to our team here, mention you were on the webinar, and they do have special discount pricing available to you for attending the webinar. Also, please follow our blog at sanbolic.com/blog. Lots of interesting technical information. And if you'd like to know about any of the other upcoming events, you can follow us on Twitter @Sanbolic.
David, I would also mention that we're currently available on a bring your own license model within AWS, including SPLA pricing. We're working on getting our product into the Amazon marketplace and hope to have it in there shortly. So, Q&A?
Great, terrific. Well, Dave, Miles, Bill, thank you very much for a great presentation and overview of Melio and SQL Server on AWS. Folks, if you've joined us midstream, we invite you to submit your questions still, and we'll open it up for some Q&A. Dave, I'm going to point this question first off back to you. The attendee is asking, what type of application coding changes are needed for Melio?
For Melio, there's no application coding changes that are needed. So any application that's already written to work with SQL Server can use our software directly without issue. What I would say is it really depends on the type of clustering you want to do. If you want to do instance level clustering with that cluster, you don't have to change anything. It's going to behave much like failover clustering, except you're not going to get any of the limitations. You'll get the consolidation of the shared storage. You won't get the limitations around what types of SQL additions you can cluster or how many servers you can cluster. If you want to do the database level clustering, that's where maybe you might need to make a couple application changes. So if your application addresses multiple databases and you want to have those databases in separate resource groups, you have to keep in mind that a resource group will have either an elastic IP address or a virtual IP address associated with it. So if you split a database, if you split two databases and put them in different resource groups, your application will need to be written to have two application connection strings, right? One for the virtual IP or elastic IP for one resource group, the other for the other virtual IP or elastic IP in the other resource group. If you put all the databases for a particular application in the same resource group, then like instance level clustering, you shouldn't need to change anything.
Okay. Next question is, I'll point back to the Sanbolic team, is does this application support and work with SQL servers in multiple availability zones on AWS?
Yes, you can absolutely have the servers separated in different availability zones. If you're going with your own virtual server storage approach, those can also be separated into multiple availability zones.
I'm going to paraphrase this next question and point it back to you, Team Sanbolic. The attendee is asking, he heard you say that you allowing to remove dependencies from a failover clustering. They're slightly confused by that terminology, and the question is, when it comes to distributing transaction controller support and dependencies on failover clustering, is that supported in this application?
That is something I would actually have to look into and get back. So if I can get that gentleman's email address, I can follow up with him directly.
Sure thing. Great. So Miles, I'm going to point this question back to you, but can you articulate from an Amazon perspective what versions of SQL Server are supported?
Sure. We support several different editions and different year releases. So from the AWS side, any software that runs on x86 you can run on us. So that general bar is pretty low. You can run almost everything. Now, from a licensing perspective, it's important that you recognize that for most applications, the terms of your license are an important component of where it is that you're allowed to run software. We have a program called License Mobility that allows you to take advantage of one of the benefits of software assurance to migrate existing physical licenses, both per core or per processor licenses for SQL Server in several different editions to be migrated to run in AWS following kind of a bring your own license model. Internally to AWS, we sell via Microsoft SPLA SQL Server 2008 and 2012 web and standard editions only. So I think that covers it.
Okay, great. Thanks, Miles. Another question specifically, I'll point this back to the Sanbolic team, is does the application run on IBM kind of enterprise mainframes? And
yeah, you can.
Oh, I'm sorry. Sorry,
Okay,
David.
go ahead.
If so, can you speak to kind of the various operating systems that it's compatible?
Sure. So you can absolutely run it on IBM-based servers. We are an IBM partner. In terms of operating system support, today we're currently only shipping for the Windows platform. So Server 2003, R1 and R2, 64-bit only. Server 2008 R1, both 64 and 32-bit. Server 2008 R2 only comes in 64-bit, and Server 2012. What I would say is I would sign up for our mailing list, watch closely, because there may be announcements coming up around additional operating system support, but nothing we have announced publicly yet today.
And the other thing I'd add is if you're running it in a hybrid environment, part of which is on-premise, we're agnostic as to what hypervisor you're using in a virtualized environment. So it could be Hyper-V, it could be VMware, it could be KVM. So we're agnostic if you're running a Windows virtual machine on-premise in a hybrid environment. It doesn't depend what hypervisor you're using.
Okay, cool. We have a question around security, and I'll point this back to any of you that want to jump on this. The question is relative to, can you speak to the security in place for whether it's federal or government or HIPAA, and then other maybe local agencies in terms of what kind of security licensing both the platform application has in place?
I don't think I could speak to that. Have to follow back up with that particular user. Okay. I can go to our government team here and sure they have all that information. I don't have that on hand though.
Okay, great. So we've got time for just a couple more questions, folks, but please keep your questions coming, and if we don't get to them, we will follow up with you offline. This question is there plans to support SQL cluster servers on AWS? Miles, are you still on with us?
Yeah, I'm available. So there are many different flavors of clustering for Windows and SQL Server workloads. We're working closely with Microsoft to work through the different requirements for their clustering technologies. And while we have some promising experiments going on, and we have some places where we're hopeful to push the ball forward, we don't have current support for SQL Server clustering on AWS.
Okay, great. One other question in terms of the licensing, and I'll point this back to the Sanbolic team, is can you speak to what kind of licensing? You mentioned that folks can bring their SQL Server licenses over. Can you speak to that in a little more detail?
Sure. So if a customer is running their Melio license on-premise right now, they could migrate that onto a Amazon instance. We also, for Amazon, have SPLA pricing that our sales team could follow up and provide you details on. We do intend, hopefully this quarter or shortly thereafter, have an AMI in the Amazon Marketplace that has Melio pre-installed that will facilitate the deployment of these kinds of architectures. And that will be obviously a more granular pricing model as Amazon does.
All right, great. Well, I want to thank our presenters today.